you guys is, what is the difference between rational and irrational?
Irrational starts from 0, right?
Somewhat. It can start from 0, but 0 is not an irrational number. So I want you guys to think about rational behaviors and irrational behaviors. What's somebody like that's being irrational? Nobody? So when somebody's being irrational, it means they're being crazy, absolutely crazy. There's no pattern to what they're doing. There's no reason for what they're doing. They're just being crazy, okay? Versus a rational number. What do you think rational is then? It's a normal number, okay? So, and we'll go through and I'll break down in the next section what's the true difference. Yep, you go ahead and write it. I try to do not just use the textbook definitions, try to give you guys more than that. Okay, so we'll look at something that's a crazy number. So I want you guys to go down to number 7. Type that in your calculator. Do negative root 2 into your calculator. What did you get? Okay, negative 1.4142135, and so forth and so on. So is that crazy or is that a normal number? How would you classify that? Normal or crazy? It's crazy. So therefore, we would mark this off as an irrational number. Why? Because it is a non-repeating decimal. That's what really is what an irrational number looks like. Okay? So, let me erase this part and we'll go through some more of these. Now, let's do this one, number 3. Negative 3.9. Do you think it's an integer, a rational number, or an irrational number? What makes something an integer? Nope. Nope. It's not even an integer. Integers are whole numbers only. It's not a whole number. There's a decimal there. But it is rational. So why is this decimal rational on number 3 and number 7's decimal is irrational? Why is number 7's decimal crazy? But this one's not.
Because we got numbers after it.
This does have how many numbers? And does it ever stop? Do you think this is ever going to stop? No. 7 never stops. But this is 3.9. So what happens to this decimal that makes it rational? It stops. The decimal stops. Okay, remember, the mic picks you guys up. No, Johandi was not talking, but he hears the stuff. Yes. He'll get it later, but yes, I'm recording for Johandi. So every day I'm going to do this so that way he can hear the lesson. And then, even though like I'm talking right now, he's going to hear all this. And he'll probably laugh. Okay, so continuing. So the difference between the decimal in number 3 is rational because it stops. But this is irrational because it's crazy. It just keeps going, and there's no pattern to it. All right, so let's look at number 1 then. 7. Integer, rational. It's an integer. Why? This is a whole number. Her name is Rainisha. Yes, she is. Okay, so don't get tricked on number 2 though. Look very carefully at number 2. Do you think this is an integer, rational, or irrational? Why?
Because the numbers continue.
The numbers, the dot, dot, dot that you see means that that continues. So this is irrational because it is a non-repeating decimal. And like you said, it doesn't stop. Crazy people never stop. They just keep going. All right, so let's look at number 4, square root of 36. Do it. What's the square root of 36? Came out to be a whole number. It's an integer. Okay. What about 2 over 3? Do it. Do. Now, what happens when you're trying to do 2 over 3? How do we type it into our calculator? 2 divided by 3. So type in 2 divided by 3 into your calculator, and what do you get? 6, 6, 6, and the 6 keeps going. The 6 keeps repeating itself. Okay? So, now, is that crazy or is that not crazy? Okay, so the question was, is it rational because the 6 keeps repeating? It is. That's not a crazy number. I do the same thing every single day. Does that make me crazy? No, I mean, well, yeah, I work here at Corcoran, but it doesn't make me that crazy. So this one would be classified as rational because the decimal repeats. And if there's repetition, that doesn't make us crazy. Okay. All right, now let's do 6. Negative 1.233 dot, dot, dot.
Irrational.
It's irrational because there's no what? There's no ending, and the decimal does not do what? It does not repeat. So this is a non-repeating, and it doesn't stop. What? We already did number 7. Now number 8. That one should be easy enough. Because it's a whole number. Now, be mindful, all integers are rationals. Same thing here. All integers are rational numbers. So there's not really much difference between really an integer and a rational number, except for that the only thing an integer can be considered as is a whole number. Okay. Well, what's 12 divided by 5? What is it?
2.4.
This gives me 2.4. And yes, it is rational.
We done?
No, he's being stupid. All right, any questions so far? Okay, so let me erase this. Okay, I reckon I'll give you 1 second, Matt.
We only do 1 page a day, right?
We would only do 1 page a day, but this page goes together. Be quiet, Matthew. You need this. All right, read it.
The domain would be the most appropriate set used to the function.
Okay, so we're talking about a domain. What's domain? Yes, x values. Okay, they are x values. So that means we're talking about an X and a Y. Which one is which? They talked about two different things, the number of online devices versus the number of people. X represents the online devices or the number of people? It's the number of people. So X's are your number of people, okay? Because the online devices depend on the number of people in the household, okay? So that means the online devices are my Y values. So we're solely talking about X values. So all we're talking about are number of people. So we're talking about number of people. Will we classify them as integers, whole numbers, irrational or rational numbers? Anybody want to take it? You think irrational might work or no? Right? Why won't irrational or rational numbers work? Because these have decimals. Can you have a decimal? It is whole numbers. It is a whole number. She's right. Now,
The integers is like, ain't them like fractions and stuff too?
rationals will be fractions. Integers, the difference between an integer and a whole number. Integers are positive or they can be negative. But the whole numbers, when you're talking about whole numbers, they're the counting numbers, 0, 1, 2, 3, dot, dot, dot. Whole numbers can only be positive. Integers are positive and negative. Can you have a negative amount? Can you have a negative amount? Can you have a negative amount of people? No. So integers has to be out because we're not considering the negative portion of it. No, whole numbers are from 0 on. They're called the counting numbers of how they count. And this is how they trick people on the Regents exam. So on the back here, I just want you guys to find the value of the expression. Don't worry about rounding it. Just find the values. So I'll model so this way you guys understand the clear expectation. Okay? Now we're going to state whether the expression results in a rational or irrational number. So what's L? Mathematically? Nope, from down here in the table. L is the square root of 2. So we're going to do the square root of 2 plus m. 3 radical 3. Now, be very careful when you type this into your calculator. You do not want this bar here to be over all of it. You do not want it to look like this in your calculator. You don't want to see this in your calculator. When you get to the end of this 2 right here, it blinks like this as a right arrow. So you would touch the right arrow key to get out from underneath it to make sure that you're getting it. Okay. So I want you guys to go through and actually do each one of these. Tell me what the decimal is, and then classify it, remember, as rational or irrational. Okay, so you guys should be able to do, now that you have enough information about rational and irrational, I want you guys to do 11 and 12, and then I'll go over them. Johandi, good luck. I hope this helps you. Let Ms. Priano know if you can't access this or have an issue with it.